Welcome to another episode of Geovoices. Today, we're delving into the world of compositional data analysis, specifically its application in geochemistry. Our focus will be on two papers, one offering a guideline for analyzing compositional data in immunology, and the other presenting a workflow, GeoCoDA, for lithogeochemical data analysis. For our geologist audience, how relevant is the first paper, focusing on immunology, to our field? While disparate, the underlying statistical challenges are remarkably similar. Both immunology and geochemistry deal with compositional data relative proportions of different components that sum to a constant. The methods for handling these proportions, particularly the logratio transformations and Dirichlet regression, are directly transferable between fields. The core concepts of dealing with compositional data are universal. Let's start with the immunology paper. It highlights the importance of treating immune cell data as compositional. Why is this crucial, and what are the pitfalls of ignoring this compositional nature? Ignoring the compositional nature leads to flawed statistical analyses. Standard methods assume independence between variables, which is violated in compositional data where components are inherently related, they must sum to one. This can lead to spurious correlations and inaccurate inferences. For example, if you're looking at the proportions of different immune cells, an increase in one cell type necessarily implies a decrease in at least one other. The paper discusses logratio transformations and Dirichlet regression as solutions. Can you explain these methods in a way that's easily understood by geologists familiar with ratio analysis? Logratio transformations address the correlation problem by analyzing ratios of components rather than the absolute values. This is similar to how geologists frequently use ratios like Mg or Fe in igneous petrology. Dirichlet regression, on the other hand, models the compositional data directly using a probability distribution specifically designed for compositional data, the Dirichlet distribution. It's a more direct approach, but the interpretation can be more complex. The immunology paper uses these methods to analyze colorectal cancer data. What are the key takeaways from their findings regarding racial disparities in immune cell composition? Their analysis revealed significant racial differences in the relative abundances of certain immune cell types, suggesting potential implications for cancer diagnosis and treatment. However, the specific details of the findings are less relevant to our geological context than the methodological approach itself. Now, let's move on to the GeoCoDA workflow paper. This paper focuses on lithogeochemical data, a much more familiar domain for our audience. What are the key advantages of GeoCoDA? GeoCoDA provides a structured workflow for analyzing geochemical data, emphasizing both process discovery and supervised learning and process validation supervised learning. It leverages the power of logratio transformations to identify and validate geochemical processes reflected in the data. This is crucial for understanding the formation and alteration of rocks. The paper highlights the importance of logratio transformations. Could you elaborate on the different types of logratio transformations, ALR, CLR, and their applications within GeoCoDA? ALR additive logratio uses a single reference element, simplifying interpretation but potentially biasing the results if the reference is poorly chosen. CLR-centered logratio uses the geometric mean of all elements as the reference, offering symmetry and avoiding bias from a single reference. ALR isometric logratio is more complex, mathematically elegant, but often harder to interpret geochemically. GeoCoDA primarily uses ALR and CLR, prioritizing interpretability. The paper uses a kimberlite dataset as a case study. What insights did GeoCoDA provide regarding the different kimberlite phases? GeoCoDA successfully identified distinct geochemical signatures for the 5 kimberlite phases. By analyzing logratios, the workflow pinpointed key elemental ratios that effectively discriminate between these phases, offering valuable information for diamond exploration. The analysis went beyond simple visual inspection, providing statistical validation of the differences. The paper employs both unsupervised and supervised learning techniques. How do these approaches complement each other in the GeoCoDA workflow? Unsupervised learning, like clustering, helps discover inherent patterns and groupings within the data without predefined categories. Supervised learning, such as classification trees or logistic regression, uses these patterns to predict or classify samples based on known categories, in this case, kimberlite phases. The combination provides a more complete understanding. The paper mentions the issue of compositional zeros. How does GeoCoDA handle this common problem in geochemical data? Compositional zeros are a significant challenge. GeoCoDA acknowledges this and suggests several strategies, including imputation methods for missing values and the use of alternative methods like correspondence analysis (CA) that can handle zeros directly. The choice of method depends on the nature of the zero's structural vs analytical. The paper explores various multivariate techniques, including PCA and correspondence analysis. What are the advantages and disadvantages of each in this context? PCA principal component analysis on clear transformed data is a powerful dimension reduction technique, revealing the main patterns in the data. Correspondence analysis (CA) is particularly useful for data with zeros and offers a different perspective on the relationships between elements and samples. Both are valuable tools within GeoCoDA. The GeoCoDA workflow incorporates amalgamations of elements. What is the rationale behind this, and how does it enhance the analysis? Amalgamations, or summing elements into groups, are based on geochemical knowledge. This allows for a more interpretable analysis by focusing on geologically meaningful combinations of elements, representing specific processes or mineral assemblages. It simplifies the data and improves the clarity of the results. In the context of supervised learning, the paper explores logistic regression, classification, trees, and random forests. What are the relative strengths of these methods for predicting kimberlite phases? To summarize, both papers emphasize the importance of acknowledging the compositional nature of data. The Immunology paper demonstrates the application of advanced statistical methods to a biological system, while the GeoCoDA workflow provides a practical, step-by-step guide for geologists to analyze lithogeochemical data. Thank you for this insightful discussion.
Welcome to Geovoices, your go-to YouTube channel for concise and engaging videos on geology and the latest geological news. Whether you're a seasoned geologist, an earth science student, or simply an enthusiast, Geovoices offers insightful content that caters to a diverse professional audience. Stay informed with our expertly curated updates on groundbreaking discoveries, innovative research, and practical insights from the field. Join our community and enhance your geological knowledge by subscribing to Geovoices on YouTube. GeoVoice.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.